All right, so next we're moving on to the compound angle formulae. So here, here's a summary with the compound angle formulae for sine alpha plus beta, sine alpha plus beta, sine alpha cos beta plus cos alpha sine beta. Sine alpha minus beta is sine alpha cos beta minus cos alpha sine beta. Cos alpha plus beta is equal to cos alpha cos beta minus sine alpha sine beta. Cos alpha minus beta is cos alpha cos beta plus sine alpha sine beta. Tan alpha plus beta is equal to tan alpha plus tan beta over 1 minus tan alpha tan beta. And tan alpha minus beta is tan alpha minus tan beta over 1 plus tan alpha tan beta. So those are your compound angle formulae. Now it is a part of your syllabus to know how to derive your compound angle formulae. But before we get into deriving it, let's have a look at this. Here I'm talking about the vertical and horizontal component of C. So C could, let's say, for example, be a vector, or it could just be some line. B is the vertical component, and A is the horizontal component. The angle, C makes an angle of theta with the horizontal. All right, what I want to point out to you is that B, which is the vertical component, is equal to C sine theta, and A, the horizontal component, would be equal to C cos theta. Now, of course, we can prove this using trig ratios. So the side that is opposite to the vector, the vertical component, would be C sine theta. The horizontal component would be C cos theta. As I said, we could use trig ratios. This side is opposite to the angle, and A would be adjacent. So the trig ratio that includes opposite and hypotenuse, C is the hypotenuse. So sine, because the trig ratio that includes opposite and hypotenuse is sine, we want to find B. The sine of theta is opposite B over the hypotenuse C. Cross multiplying, we get that B, which is the vertical component of my vector, is equal to C sine theta. So remember, that's what I gave you in the summary. And the cosine of theta is adjacent A being the horizontal component of the vector, over the hypotenuse C. Cross multiplying, we get that A, the horizontal component, is C cos theta. So we need to be able to say what the horizontal and vertical component of a vector is. All right, let's go into the proof. All right, so we're going to use this diagram to prove that sine A plus B is equal to sine A cos A plus cos A, this is not correct. Sine A cos B plus cos A sine B. All right. So let's double check in. For some reason, my brain is shutting down a little. Yeah. All right. So let's see how they would do this. All right, what they would do is that so we start off with we could say it's an acute angle triangle. All the angles measure less than 90 degrees. Starting from here, this vertex here, I drop a vertical line. So this is my vertical line. That's the height of the triangle. It forms 90 degrees with the base. That divides the angle at the top. So I'm going to call the two parts A, angle A, and B. Let's call here X. Let's call here Y. And let's call here Z. All right, we're going to need to find X, Y, and Z in terms of A, B, and C. Now, based on what we just did, I can say that X is equal to A cos A, and Y is equal to A sine A. The horizontal and vertical component. I can also say that X is equal to B cos B, and Z is equal to B sine B. Now, of course, you could show that using trig ratios. All right, so now I can let us use area to prove the trig identity above, that sine A plus B is equal to sine A cos A plus cos A sine B. All right, so let's look at area. The area of the entire triangle. The area, using this formula, a half AB sine C. Now, where A and B are the what? Two adjacent sides, and C is the inclusive angle. Now, in this diagram, the inclusive angle is A plus B, and the two sides are A and B. So the area here is what? A half AB sine C, which is the angle A plus B. C being the inclusive angle, the angle between A and B is A plus B. Now, area, I could also find the area of this entire triangle by finding the area of the two smaller triangles. So the area of the triangle on the left, and you have the triangle on the right. The area of the triangle on the left, so let's say area of L, the one on the left, is equal to a half base Y times height, which is X. So it's a half. Now, Y is equal to A sine A. And X, for X, I'm going to be, remember, X is two things. If you look here, you see that X is A cos A, and X is A cos B, is B cos B. So I'm going to use B cos B. So this is multiplied by B cos B. Now, the area of R is equal to half the base Z times the height, which is X. So it is a half of Z, which is B sine B, and x, for x, I'm going to use A cos A. So here, this is a half AB sine A cos B, and over here, it is a half AB, let's go with cos A first, cos A sine B. So the entire area, which is a half AB sine A plus B, is equal to the sum of the area of the two parts, the triangle on the left and the triangle on the right, which would be equal to a half AB sine A cos B plus the area of the triangle on the right, which is a half AB cos A sine B. Now, if I divide the entire equation by a half AB sine half AB, if I divide the entire equation by a half AB, I'm going to end up with sine A plus B is equal to sine A cos B plus cos A sine B. And so this is my double angle formula, and this is the method used for proving it. And you are expected as a part of your syllabus to know how to prove this double angle formula.